Hi, I'm Danny. Welcome to the workshop. What I really love about 3D printing is that when you have some product that is already outdated and has no spare parts, you can create one by yourself and print it and fix a favorite stuff, or even you can find a part online and again print it and fix your stuff. That's what happened with a friend of mine. He has a very old coffee machine and he needed a part for it. So he found an STL file, sent it to me, and asked it to print it on my 3D printer. However, when I printed the part, it was breaking on one particular spot. I was wondering why. I checked in the slicer, run fixing the slicer of the mesh, print it again, and I ended up with exactly the same result. This is when I decided that I will put this part in SOLIDWORKS and check it out what's wrong with it so I can modify it or rebuild it and print it for my friend. So now let's see actually what's wrong with that part in SOLIDWORKS. When you're opening a mesh file just as a reference, you want to make sure that it comes in particular file format. You can go to Tools, Options, Import, STL Object, and make sure you have selected graphic body for this import. Alternatively, when you go to open the file and you click on it, you will have the Options button. However, due to a bug, sometimes this Options button is missing. So if you miss the Options button, just go Tools, Options, and change the settings the way you want. Otherwise, you can click here and it will go directly to the right file format so you can change its options. I will open the part. Now it's importing in white, which is kind of very close to my background. That's why the first thing I will do is change the appearance to a different color so it's more visible. The other thing which I want to do is to shade it with edges so we can see all the mesh triangles of the part. And now we can investigate what actually is wrong with that part. As you can see from the outside, it looks perfectly fine. That's why we will go to a section view. And usually when you go to a section view, this option here, graphic only section, is disabled and you will receive this message. If you ignore the message and just try to see the section view, you will notice that actually nothing is visible. This is because you have to enable this option, graphic only section, and this will show section view of everything inside your model. Why you need it as a separate option? When you're building with reference geometry bodies inside your file, sometimes you don't want to see the mesh files and you want to see only what you're building. Then what you have to do is just uncheck this and you will see only your part. But we will check this out a bit later in that video. For now, we want graphics only section and to see inside of our part. What I notice immediately is this strange internal cut, which is absolutely wrong. There is no reason you need a smaller thickness here. You can see that the person who did the model actually don't know modeling very well, and this is resulting to this very thin area, the place where my part was actually broken. What we have to do now is actually rebuild the part in the correct way, so we have the internal area almost same and we have the external area the same. As I said, that's a part for a coffee machine. I don't have the original part to reverse engineer it myself, so I needed to work with the STL anyway. This is a simple part, and the best way to rebuild it is literally rebuild it. We don't need to use convert or something like this. The best way is just to rebuild the part as it is. And the other thing is we want to change the inside too. So what I'm going to do now is to make a 3D sketch with some circles around the part and some radiuses here for the fillets, some curves. In my previous videos, I was telling you that you can make a sketch snap to STL file only when you're in 3D sketch. And that was true. However, I did have a discussion with the R&D team of SolidWorks regarding STL and work with STL in SolidWorks. And I mentioned about this particular thing that's quite annoying, because sometimes when you don't work with tubes or circular things, it will be much easier just to go to front plane, add a new sketch, and start snapping 2 points from your STL. This was not possible. They were surprised, to be honest, and what they did is literally in the next revision of SolidWorks, you were able to snap to any visible vertex from a normal 2D sketch. And that's great. That's amazing, very useful for some other shape, unfortunately, not this one. So now we will go with the old-fashioned 3D sketch way. You want to take a perimeter circle and start recreating circles around. I start with this one, no matter that's not outer diameter or something, because this is defining my end face. The same I will do also for here. And to be easier for you to work, make sure that shaded sketch contour is disabled, because it's a bit easier when you have to make a lot of circles snapping around. It will work also when it's enabled, just it's harder. Once we have defined the outer diameter, the end faces, we would like to define also the inner one. I snapped to the wrong point. It happens sometimes. You can always zoom a little bit more to have a better view. And what we miss now is actually this inner. Then I will go to 3-point arc to define my fillets. I don't want to go directly with the endpoints, as the mesh is disturbing a bit the shape, so I'm going to the areas which look nice. And the last thing I want to do is to dimension the fillets. So once I click on the 3D sketch, I will be able to see the sizes. Oh, I missed one radius here. This one is also important, as we will make this one with fillet 2. And then we start dimensioning. Now when I have all my fillets measured, I will go out from the 3D sketch and I will start building my part. I will start from the top plane, converting the most outer diameter. Then I will use extrude boss from vertex, and I will choose the one here, and then up to vertex, and I will choose the one which is corresponding to the end face. Then what we want to do is I will hide the graphic body and I will make a new sketch here, again converting this, and I will convert also this one, so I can keep the reference without a problem. I will make this construction geometry and add a line which is on the intersection of both. Then I will trim out what's not needed, and the next step will be to make a revolve boss base on the 90 degrees angle. My next step will be, let's check our 3D sketch now. We have a radius 7 here, which means to form this correctly, we need a minimum of 7 mm extrude boss base from here. I will add a new sketch here, convert the entities. I will just delete this line, finish the circle, and I will make extrude boss base, which is blind 7 mm long, and we don't want to merge that one. If we merge it, we won't be able to make this fillet. That's why I won't merge it. I will create it and then go and make a fillet on the edge, which is with radius 7 mm. At this point, we can merge everything together, and we can do this from tools, from insert, I'm sorry, features, combine. We use operation tab, add, and we select the two bodies. Alternatively, if you like me have here direct editing is a tab, very useful tab, and I always keep it on top. You have this option here. Now it's grayed out because we don't have two bodies. Once we're ready with this, we want to make a shell of this shape, and to do this we need the thickness of that shell. We go to the evaluate tab, take the measure, and measure from this inner circle up to the out face. Make sure you're on the minimum distance, and you will see it's 1.74998 or 1.75. If you want the exact value, you just click it here and you will copy it. Then we go again to the features, shell, select the face that we want to remove, and paste the value that we just copied. You can show preview if you want, and then accept. Now we have the part which is shelled out, and what we need to do next is to build the other tube going there. So for that reason, I will go to the right plane. We can see here that this is the outer diameter. We convert the entities, and then we make, either we convert also the inner one, or we can leave this for later. I will leave this for later. We go to extrude boss base, and we want this to be from vertex again, which is the one here, and it's hard to select because our sketch is overlapping. So if our sketch is overlapping, we can say okay, then it's sketch plane, and we go up to vertex, which is the one here, and merge result. So in this case, actually we didn't need to combine. Oh, we need it for the shell. Now what we have is this shape here, and what we want to do next is add a new sketch here. This is the inner diameter, convert it, and we make extrude cut up to surface in this case, and we come up to here. Now this is now the correct shape based on what we had, because we have for this smaller diameter and face here. Oh, excuse me, it should be even here. I will correct this. I will go to that point, and now we have it in the right way. Alternatively, if you don't like this edge, you can go to direct editing and delete this face. And this is the shape that you will receive. Now we can hide the 3D sketch and see the shape as we have it. This is based on the original part, but without the strange cutouts. And this is if we want more smooth surface and more equal thickness. I will leave mine like this because I like it more. With this we will have a better print, and based on the function I know of this tube, it's totally fine to have it that way. What we need to do next is actually to add the fillets. If I click on the 3D sketch, no matter that is hidden, I still can see the values of all the radiuses around. I will start with the ones on the front. We have outer of 1 and inner of 0.6. And on the other end we have 0.5 two times, which means that we can select 0.5 and directly the face here. This is our part, and as I promised earlier, I will show you what's the difference with the section view and graphic body enabled or disabled. Now I will show our graphic body. Actually, to have it better visible, I will change the color of the body that we created to a different one, so we can clearly see the difference between the two parts. Now the gray is our original part and the green is the one we created. As you can see, it's really representing well the original mesh file that we have. And now when we have the section with graphic only selection, we will see both what we have created. As you can see, the additional thickness we do have here, and these strange angles here disappeared. This is our part. Now, however, when we look both on the mesh and our model, it's looking really strange. So if we go to the section view again and say graphic only selection disabled, the only thing we will see in the section view after the section is done is our part. As I said, that's really useful when you work with reference parts in the way of a graphic object inside your model. What we can do now is just save our file, and then we can export it either as STL or as step file, depending on what kind of slicer we're using, what we prefer. I literally prefer to use step files because I can control during the import in the slicer the quality of the STL itself. Okay, now we can hide the graphic body and see our final part, which was recreated quite fast. And well, that's it. It wasn't that hard. Unfortunately, no matter how advanced are our slide softwares, they cannot fix errors that are due to the modeling of the part. And this error is quite often because users which are not so advanced with the modeling software, they're trying to achieve things with the most simple tools. They use cut, they use revolve, and they make undercuts. Sometimes they can make really thin faces. That's fine. We all learn with the time. However, in this case, this particular modeling technique was making the part weak. And this was not visible in the slicer software. That's why we needed to investigate it inside SOLIDWORKS to find the problem, fix it or rebuild it, and to print this part. After I remodeled the part, it printed perfectly, it was strong enough, and my friend is still using it in his house on his coffee machine, and he's extremely happy. I'm happy too, as one coffee machine continues to serve a great coffee to its owner. I hope to see you next time. Bye bye.